Hello everyone and welcome back to the channel. So today we are going to be looking at this question. It says that solid A is mathematically similar to solid B. The height of solid A is 7 centimeters and its surface area is 60 centimeters square. The surface area of solid B is 540 centimeters square. Calculate the height of solid B. Alright, so the first thing we need to take note of is that these shapes, or rather these solids in this case, are similar solids. That means they have something in common. Now, apart from their shapes, another thing that they have in common is the ratio of their sizes. So when we say that two shapes or solids are similar, it simply means that there is a ratio in their sizes. It is either, let's say, 1:3 or 2:4 or whatever. It doesn't really matter what the ratio is, but the most important thing is that there is actually a ratio. So that is what we are going to find out. So let's begin. So we would have used the height as a reference, but because we don't have the height of the big shape, which is actually what we're looking for, we are going to be using the surface area as a ratio. If we can find the ratios of the surface area, then we can find the ratios of the height, and then in turn find the height of the bigger shape or the bigger solid. So let's look at ratio of small solid to big solid. The ratio is equal to the ratio of the small solid, which is 60 cm squared all over 540. So if we solve this correctly, we have this to be 6/54. All right, and 54 divided by 6 is 9, so we have 1/9. So this means that the ratio of small shape to big one is 1:9. So this is where many people make the mistake. Many students feel that once you have this ratio, you just use it to find the height of the solid. So what they will say is that if the height of this small solid is 7, then the height of the big one should be 7 times 9. But that is completely wrong. That is where they make the mistake, because we must take note that the ratio we just found is the ratio of surface area and not the ratio of length. And one thing about the ratio of surface area, or any area for that matter, is that it is always unit squared. So for example, the surface area of the small one is 6 cm squared and the surface area of the big one is 540 cm squared. So because of that, we cannot use this ratio directly to find the height of the big shape, because the height is not squared. So what do we do? For us to be able to find the ratio of the unit length, we have to square, or rather find the square root of the ratio of the area. So ratio of lengths is equal to the square root of the ratio of areas or surface area. So that means that this should be equal to the square root of 1/9. And when you find the square root of 1/9, what we will have is 1/3. So therefore, this ratio is equal to 1:3. That is what it means. So now that we have found the ratio of, I don't know why I kept writing ratio. So now that we have found the ratio of the lengths, so we can now apply that. We can now plug it into the solid shape. That means the height of the shape is equal to 3 times 7, which is equal to 21 cm squared. All right, so this is how you solve this question whenever you see it. So if you enjoy this lesson, make sure you like, you share, and subscribe. And I'll be seeing you in the next video. Have a lovely day and goodbye.